my u, what am I going to have to pull out for my du? So let's just kind of remember, if I can get everything in terms of sine x, what am I going to need pulled out for my du? I'm going to need a cosine x dx. If I picked cosine, what am I going to need? I'm going to need my sine x dx somewhere manipulated, okay? If I had picked secant, what am I going to need pulled out? Secant x tan x dx. And if I had picked tan for my u, what am I going to need pulled out? I'm going to need a secant squared x dx. So our goal as we go along is we are going to pull these out. Okay, so get that pulled out and see if whatever is left you can get in terms of sine, or in terms of cosine, or in terms of secant. Everything else will need to be in terms of that. That's our goal. So we're going to use some of those trig identities and stuff to help us get there. So let's look at this first one. What is something that I think I could pull out? We'll just talk about it. Sine? Okay, what about a cosine? Could I pull out a cosine? Okay, if I pulled out a cosine, don't write this down. I'm going to be left with cosine cubed and sine cubed. Right? So if I had pulled that out from my du, can I get everything else over here in terms of sine? Well, if this was a cosine to the fourth, I could use some trig identities. Or squared, or 6. But can I use the trig identity, that Pythagorean trig identity with a third, or any odd? Okay, so basically I don't want to have odds left. So what do I need to get pulled out? Okay, so let's pull out one of the sine x's dx. And that's what I want to have pulled out over there for my du. So what's going to be left? A sine squared x and a cosine to the fourth x. So now that I have this pulled out for my du, I want to get all of this part in terms of what? In terms of cosine x. So I want to get all cosines over here now, if that's going to be my du. Does that make sense? Okay. So, question. Okay. So what am I going to have to do? I've already got this one. That's good. This one is not in terms of cosine.
1 minus cosine.
Okay, so I can put that as 1 minus cosine squared x times cosine to the fourth x. And then I still have that du part pulled out. Oops.
Are you calling it a du part?
Because that's when I do my substitution of u's.
That's what we're talking about.
That's what I need to have for a du.
Okay.
Because basically I'm going to be using this one now. I'm going to make u cosine, which means I'm going to have a sine dx. Okay? I'm going to go ahead and distribute this first. You could have done a u sub now. I don't know. I just like to see it all over here and methodical about that. So that's how I like to see it. So I can see that now all of the stuff in the parentheses is going to be a nice u sub with a du over here. Does that make sense? Okay, can you finish this pretty easily now? Yeah, go. And I'll kind of write up as you go, you can check and see. Why did I switch my order for u to the 6 minus u to the 4? How did I go? Why did that switch? Because of this negative, right? So when I pull out the negative over here, so it'd be like a negative du equals sine x dx, then the negative distributive would flip-flop that over. What's that? Yes. Cosine. Okay. Questions so far? Ask if anybody in your group has a question so far.
Oh, thank you. Thank you very much.
That's interesting.
All right, let's look at this one now. I don't want to worry about my bounds yet, so I'm going to do some intermediate work and then go back when I get my answer and put in my bounds. I don't want to have to write pi over 6 and pi over 3 like 10 different times. Okay? Save some time. So I'm going to come down here and do some intermediate work. Now, when I first started, we kind of said, well, this rows, we want them in the form like this. That doesn't quite look like that, does it? How can I make it look like that? Okay, so I can make that cosine cubed and sine to the negative 1/2. What do we want to have pulled out for our du here? A cosine or a sine? A cosine, because after I get one of those pulled out, I'm going to have a cosine squared, and can I get that in terms of a sine? Okay, so keep going. See if you can kind of keep going, and I'll keep going. You have a question about anything I write up, just pause me and just kind of trying to go, listening and go. Two plus a half, 3, 3, 4. So I want to make sure you guys all get to that before you start doing a U set.
Only to be ironic. Wait, guys, hold on. Where did cosine go? Guys, where did cosine go? What cosine? What's cosine? Oh. Oh, yeah, never mind, they have 1.5. Okay, so that's not there.
So you equals
Sine x. Cosine x dx.
Oh, no.
So, after I get
no.
that intermediate work, do you think I could go ahead now and go back up to my definite integral?
I mean,
Because we definitely need to get a definite, right? Integral. So I'm going to go ahead and bring that part up and get my definite integral. So this is going to be u to the, let's see, 1/2 times 2, right?
Yep.
Minus u to the 5/2 by 5/2 evaluated from, is it pi over 6 to pi over 3? No. Okay, so I need to plug that into my u as well. So this would be sine of pi over 6 is 1/2, and sine of pi over 3 is radical 3 over 2. So you see how I kind of saving some of that work and time? Okay. And nothing is incorrect. I just have intermediate work with an indefinite, and now I have a definite equaling a definite that is all correct. Now this actually looks really ugly. You can keep your answer very ugly. So you can leave it looking ugly. If you wanted to try to get some bonus points, you could try to simplify that. But if you messed up in the simplification, you're going to miss the answer.
You'd give us bonus points?
If you got it right, if you got it wrong, you'd actually miss a point. So if you leave it like that, you're even. Okay? I won't make you do it anything worse. Okay. So looking at this one, guys, we don't have a lot of time. I'm sorry. I know. So looking at this one and back at this one, how did you tell me what we would normally want to pull out for that du? What did you guys say? We look for the what power? The odd power. So when we're dealing with sines and cosines, we want to pull out one of them from the odd power. You want to make a little note about that. They're both odd powers, and you get to pick. All right. So, cosine to the 4th x dx. What am I pulling out?
Wait,
Oh.
could you split it up cosine square things?
Okay, so there's really nothing to pull out, right? We want to have stuff left in even powers, and I don't have a cosine and a sine. So Will had a brilliant idea. He said, can I split it up into cosine squared and cosine squared? Absolutely, that's what you need to do. Why do we need to do that? If I use the Pythagorean identity, then I'm still gonna I could sub in. I don't have an odd power still, right? So that won't help us. Pythagorean identity here is not gonna help us. So we have to use something else if you want to look at your trick sheet.
Power reducing.
Oh, okay.
That's
So we have to use our power reducing. When I'm left with just an even cosine or an even sine, power reducing. You guys are talking a lot and missing what I'm saying. When we are left with just an even of one of them, we should think power reducing. Okay, you want to kind of make a note of that. So let's see what that would look like. Cosine squared is 1 plus cosine double the x, and we have 2x all over 2 times 1 plus cosine 2x all over 2 dx. So now I get to FOIL. Before I FOIL, I want to pull out the 1/4. Make my life a little easier. So I'm going to pull out the 1/2, 1/2, and make 1/4. So now I can FOIL 1 times 1 is 1. 1 of the cosine 2x, 2 cosine 2x, plus cosine squared 2x. Well, I can integrate 1 pretty easy. I can integrate a cosine of the 2x with a coefficient pretty easy. Oh, no. Okay. Let's not do that. Oh, what? Again. I get to do it again. Okay. All right. So we have to do it again.
Can we integrate the first part first?
All right. So now I'm going to say cosine double my 2x is going to be 4x now over 2. It's always over 2. Okay, so I double that guy, and it's always over 2. Double the fun. Okay, now it's kind of personal preference. If you want to pull out a 1/2 from everything, if you want to distribute and just go for it, I mean, that's kind of personal preference. I personally want to pull out my 1/2, get rid of that fraction. So if I pull out a 1/2, what do I actually have here? A 2. So it's 1 divided by 1/2, which is 2. If I pulled out a 1/2 here, then I have a 4. And 2 plus 1 just becomes 3. Now it's 3 little basic integration rules, techniques. And it's up to you how much you want to try to reduce this or pull it out or whatnot. If you want to distribute.
That's 3x.
Oh gosh, I did write cosine.
Integrate. Plus 3x.
Keep me on track. Keep me on track. Okay. All right. Thank you.
No, we did 1/2 2.
So I don't know how you want to do that. Do you want to distribute it in now for your final answer? Or if you want to pull out a 1/32 to you how you want to write that.
Yay.
Okay. So, when you just have a cosine or sine to an even power, you should think power reducing. Okay? And normally you're going to have to do it more than once. Alright? Alright, so now we're going to get to the secants and the tans. So remember, back to what we talked about for our DU, you either want to have a secant tan pulled out, and then everything else is in terms of, that's when our U would be secant. Or you want to have the secant squared pulled out, and that's when our U would be tan. Okay? So that's our goal now. So let's look at this first one. So pull out a tan. Well, we don't just want to pull out a tan, right? We either want to pull out a secant tan or a secant squared. Can I go ahead and rewrite this first? I like to just do it like this. So we can get a tan pulled out, and to get the rest of that in terms of secant. But if I get a tan pulled out, what do I need with it? Okay, so let's get a secant and a tan pulled out for our DU part. So if I pull out a tan, 3 minus the 1, I'm left with tan squared. And if I pull out the 1, then I'm left with a secant negative 3 halves. Negative 1 half minus 1 would be negative 3 halves. So if I pulled this out, I need my U to be a secant. So what do I now have to do? Okay, turn that into a secant. So use your Pythagorean identity. What? Oh, yeah. Yeah, that's that one. So I always just kind of like make a little note that I'm keeping that out so I don't get confused. That's just how I like to keep myself organized. And then I'm going to go ahead and distribute before I do my U sub, and you guys should be able to finish this. So 1 half. So finish that. Okay, anybody have questions up to here? Hold on. Okay, for this next one, this Team Jacob and Team Edward are going to build out secant squared. And for this one, you guys are going to pull out a secant x tan x for your du part. So you guys do secant x tan x. You guys pull out a secant squared and go.
Let's do this, Carla. Oh.
Secant squared? Secant x tan x.
Bless you.
Why are you goodnessing?
Yes.
7-2. Both? Yeah.
No, like, no, I know everybody cheats. You might have a new name. Same old kids.
Hey, you know what? Shows them the test. Binary test, right?
Yeah.
Good, shows them the test.
That's just because my brain.
Trying to remember. Tell me what you guys got. Over 12. One of them is mine. This one? Wait, yeah. No, we do this.
Oh, yeah, because we're changing.
No, you should. Okay. If you pulled out over here the secant squared, this is what you should have gotten. If you pulled out a secant x tan x, this is what you should have gotten.
No way.
Both are right. Oh, what? Okay.
It's the same thing he
So, I would know why these are equal. Okay? I would want to know to be able to take this and to manipulate it to get to this. Or to take this and manipulate it to get to that. That'd be something I would like to know. Okay?
Yeah.
So, it does have to do with the Pythagorean identities, and it also has to do with this plus c. So that's something I would want to know how to do. Just me, personally. Both answers are correct. All right. Last one. We may not get through this before the bell rings, but let's talk about what we would do here. I don't know. You can try to power this thing. I don't think it's going to work on that. It's only when you have the sine squared there that it comes in. So tan squared, we're going to have to do something else. We're going to have to split it up. How are we going to split that? Tangent squared and tangent squared. I know it's a lot. Come on, focus. Okay. Once we're here, and again I'm doing intermediate work, I'll go back and worry about my bounds later. Once we're here, what should we do? I'm going to change one of those to secant squared x minus 1.
Oh.
Okay. Now I'm going to distribute. I know, it's kind of like trying and seeing what we get.
Wait,
That's what I would do.
missed the minus 3.
Alright, there we go. So now this part right here becomes a what? What's your u? Right. And my du would be secant squared x, right? So I can split that. And then over here, I'm going to have to do something else now. I'm going to rewrite tan squared as what again? Secant squared x minus 1. Why would I do that? This one is just a basic. And this one is just a basic. Do you agree? So, you want to try to finish it? Go. Try to finish it. I'm going to just write, don't just copy me, it doesn't help much. Ask me questions.
Oh, wait, no. Oh, on only one of them.
That's silly.
On only one of them, because you only do
If you've got that, awesome job.
Okay, so -0 to 0, again 1.
Hey, Mr. Rose,
Hey, what?
how'd you get from secant squared to tan cubed?
Right here? So this is gonna become u squared du, which will be u cubed over 3. So I want to like kind of separate it into two problems.
Oh, wait, no. Those are mine.
All right, don't forget your 7-2 quizzes tomorrow. Several of you did not have that homework done and checked off. Make sure you do that tomorrow before the quiz if you want to take it with your group members. Got it.
Look at my notes.
What's the time of
Sally. First answer.
was hopeless